to another one. Realized I had an issue with the other one, other video. Yeah, so chapter 3. Chapter 3 is about modeling data, or what data really means in our program, and there was a very good example that was given. So it's about this dry oils, or drying oils, and curing. Basically, the example was uh, the ability to make sure that your wood doesn't absorb a lot of water, and to get an idea of how moisture absorbent your woodwork is, there is like an angle through which water make contact with the wood, and the angle that it makes and how much angle that you get is the amount of absorbing that your woodwork has, right? So the more angle you get, the better. You know that your wood, or whatever your craft you're working on, is more durable when it comes to moisture and all that. And the example was he had a specific way of measuring this, and in data oriented programming we want to be able to measure, right? We want to be able not to measure but to define what our data means. So if he comes to you and he asks you, hey, these are my measurements and this is how I make sure that my oil curing fits a specific standard, right? So let's say what are the measurements that he likes to take? He likes to take the number of days, the angle for which your oil or water makes contact with the wood, to measure the amount of absorbent quality of your wood, basically. And he has something called a sample ID. Now, my initial approach, without reading further, was okay, so you have this JSON data, right? Looks like JSON. How do we model this in Java? Java, we have records, right? And I could say measurement Java, and obviously I have to have it M, right? So here we can just do void main, and that's it, right? And we do io dot print. Let's just make sure this works, correct? And this is hi, I work, right? Something like that, right? Cool. And let's go to terminal. Now I'm just gonna make sure I'm using Java version. I think it's version 25, and it's showing me 24, which is not good, I guess, for that environment. Cool. However, let's see if this gives me a different environment. Java version. Okay, use SDK, use Java 25. Let's see if that works. That was the problem or the issue I had in the first place. Okay, Java versions, or should I just Java V if that works well? Doesn't even know what that means. Java version. 25. Cool. So now let's run measurement it works. Cool. Good. So we know that this works. So in this example, what we are more likely to do here as Java programmers is we say we want to model the data to the universe in which we're creating. In this instance is going to be like curing behavior as it's is stated here, right? And we want to know the amount in his example is okay, we see this data and we're quick to just model it, right? But we actually have no meaning. After what I said about curing, you still have no understanding of it takes days, yeah. There are variability to how moisture has been absorbed per day and all that nonsense, right? Not nonsense, but you get the gist. So here as a Java developer, I'll just create a record because I assume that I know what that is, right? We'll say, okay, we're gonna have like, let's say a string for sample what is it called, d, and we're going to have an int for let's say days gone or something, and then we're going to have a double for contact angle. Now to the arcane, right? Is this model whatever this JSON is. But the question is, we can look more deeply into the data, right, and ask ourselves, what does this mean? What is UV1 and how is it measured? So now we start with that. We get more details and we ask ourselves, okay, this is days, right? Are we measuring it in hours and seconds? Are there days where we don't measure it? Stuff like that. It becomes certain, right? Now, as a programmer, in a naive way, is to think that you're gonna be measuring this thing in the days and just the amount of like days passed, right? 24 hours, that's a complete day, blah, blah, blah. But what if you come intermittently? So you came 3 days and 4 hours. That's still the amount of time you take to measure that, right? You put that in your curing behavior handbook as a day that you measured it and how the time. And maybe 7 days goes by and you don't measure it then. And then on the 17th or the 15th day, you measure it. These are variabilities in our data that we have to account for. So this is not an accurate way of measuring the number of days. So how would we think about it with what I've said? The way to think about it is days gone, right? Like, we can name it better, right? Like instead of days gone, we can say maybe time or something, something, but I'll go with days gone. Time, days gone, or whatever, or time elapsed, time, something like that. Days gone, better. All right, here, and now we know that we have details. So I would say if we want to model that correctly, we'll give it a timestamp, right? Like a timestamp. Stamp would be one way to model it. Now, if we want to model this now, we're gonna ask ourselves, okay, angles can be measured in so many ways, right? We can have radians, we can have degrees, which he goes in depth. We can have radians, if that's how you spell it. Radians or radians? I'll say radians. And degrees, etc. Right? He measures his in degrees, right? His is in degrees, right? That's how he wants to measure it, so you have to take that into account. And now, not only do you have to take that into account, you have to think about something else, right? Like, what does this sampling means? What does sample ID is? Now, it could be a string, right? UV, right? But when I see UV, that to me sounds like an ultraviolet, right? So it's measuring more than just like a string. It tells you more about something than a string, right? So you can go even deeper to say sample ID. You see that UV 1. What does that mean? And from his explanation is that he does this thing where he has like a method, and I think he goes on to say method and a value, I believe, is what he said. He uses, yeah, method and a number, right? And he grouped them into 3, and the 3 is he has air, UV, and heat, and then he gives them a positive number. And as you can see, you can't use numbers that are greater, that are less than 1, right? So now we know not only what UV is. UV sound, the method is, to me, what I hear like an enum. The number is greater than or equal to 0, right? So we can create a more accurate sample here, right, by saying, okay, so we have these things, and say now here what we're gonna do is we're gonna say we're gonna have a record again, and this record is gonna be of type sample ID. And the sample ID is gonna have its own enum, and the enum is gonna be sample sample gauge or something, you know, I just call it something, sample gauge. This is more like that. All right, and in that you have like air, you have UV, and you have heat, right? Now it's more apparent what this is, correct? Right, it's more apparent what this is. Now in sample we're gonna have that, right? We're gonna have sample gauge, the sample gauge of, let's say, gauge, and here we're gonna have a number, right? Number, we're gonna say a number, I'm gonna say something like number. We can create a record for number as well to make it clear. Record, we have a number something, and that number can be, it's gonna be a number, let's say an integer number, positive number. There are better ways to do this, but yeah, there has to be, at least. So we have a public number, and that will check if a positive number, if number is If it's less than 0, then we want to throw illegal, maybe illegal state. Yeah, illegal state exception. Numbers cannot be less than 0. Right? Pop that. Something like that. Correct? And here we're gonna say number is gonna be number. So and I think we can just do this, right? And as you can see, we have this covered. We can actually just like do this. Let's delete 6j and let's put this here. Right, let's put it as far away. Cool. Alright, so now we're beginning to shape up. Now we have a sample gauge. That gauge is that is an enum, and then we have a sample ID that takes the gauge, and we have a number. And that number can only be whatever number we just created, right? It can be anything else. It has to be this guy. Cool. So now we've separated some concern. And here I'll just create a sample ID. Sample ID here, and this, instead of that, we'll give it a maybe local date time, I guess. And here we have to work on this as well, right? Give it like a gradient, create something that specify what this is. It can only be that. Maybe there's a Java library that does that. That is basically everything that he's talking about. Now, if I were to just go ahead and say, well, we will measure it like this, right? Just with a record, what could the problem be? There is no problem, right? Until there is, which will be a problem, because we never actually understand what our sample space is. We don't know what our system, we have an incomplete understanding of what our system should be. But by asking why, like a child, or like my daughter does, you get an understanding of what the system is, right? And I like what he said here. He said, what's the whole process for any individual? That's the whole process. For any individual idea or concept in our domain, we can get started by picking some arbitrary aspect of it at random and asking, what does this mean? And then, like a curious and slightly obnoxious child, continue asking, what does that mean? So you continue asking the same question over and over again until you reach a bedrock or our audience lose patience, right? Simple questions pursued thoroughly produce powerful results. To explore this, we're going to walk through the process of modeling a small piece of data from one of my favorite topics, and one I force into any conversation that when I have somebody cornered, which is now you reading this, right? How a class of woodworking finishes called dry oils cure over time. So you're doing some curing work over here, and the thing is, you want to know the whole background story is this. Should have started with that. When these oils interact with oxygen, they undergo a chemical reaction which converts them into a hardened film, which protects the wood from moisture. This reaction process is impossible to see with the naked eye, but it can be measured indirectly by testing how much the wood has begun to resist water, right? So this the less the angle, the more you know that your finishing or your curing is incomplete. The more the angle, the more you know that your oil curing is actually complete. And the way he measures it, he has the sample of measurements in JSON. We're going to convert this into Java. And the way you do it is here. But then you lose how he does his own. So you have to actually probe, right? You have to, if you have a project manager, you have to probe them if they know the answer to some of these questions in a domain. So you have to actually know what that means. And by that, show me your data and I will tell you how I would know the rest of your program. Basically, that's how, things go in software, and that's it in a nutshell.